just a bit of a filler video, bit of an interim, if you will. I just wanted to talk a little bit about programming bogeymen, and I'm using an ambiguous definition of bogeymen here to mean anything from like a dogma to something which is commonly taught in like college classes, but not really explained or not really dug into, through to just, I don't know, common ideas. Just, I wrote out a list and I'm going to go through some of these things. Now, the first thing here is getters and setters. So if you are in a beginning programming class, it is very common to do object-oriented programming and to talk about private variables and getters and setters. But I feel that the rationale which is given for getters and setters is actually quite weak. So the common rationale is we have some code and we have a class or something, and the class has some state, and we want the class to modify that state and nothing in the external world. Because, well, there are bad people out there who are going to jump in and call our functions, jump in and directly access our private variables and change them to bad values. So to get around that, we need a getter or a setter. But wait a second. If the bad person had a malicious intention and was going to modify our private variables, what is to stop them from calling a setter and modifying our private variables? This is the sort of situation where the test cases, the examples which are given, are just not, they're a little weak, they're a little lukewarm, they're a little anemic. Furthermore, implementing getters and setters for a private project that you're working on is a great way to ask for pain. I've done it, it's not fun, and the first lesson, the absolute first lesson I learnt in actual game development was don't do this. It's not going to lead down a good path. So if I can sort of give an alternate spin on this, there's a few cases where private variables are good. One is if you have something which is really truly just the internals of a function, then in Python it makes no difference, but in languages like C++, where using a fully featured IDE, the autocomplete suggestions will exclude that method, which makes it really useful in terms of not cluttering your IntelliSense suggestions, which is really good. And secondly, when you've got an object and the getter or the setter is its interface to the outside world, but the getter or setter is doing more than just getting or setting a variable. So when it's actually under the hood doing some processes, you know, when you call that setter, you're signaling something, but it needs to do some things in the background, which are just best left to it to handle. Pure functions don't modify state. Okay, so the reason I'm putting this out there as like a bogeyman is not because it's a bad idea, but just because it's one of those buzzwords which is very easy to throw around without throwing around the definition or the reason for that. And I see these functional bros, and it's all fine, it's all good, it's all dandy, but it would be a lot better to understand what that phrase actually means. So the big thing, this idea of a pure function which does not modify state, is really big in functional programming. And the really big, powerful idea of functional programming is that you've got like a set that you take as your input. You do some processing and you've got a set that you take as your output. But along the way, it does not matter in which order those elements are processed. The benefit of this is you can then take this and throw it at multiple cores. You can throw it at a GPU. It's like a shotgun. It just fires everything all at once. And this concept of like doesn't modify state might seem a little silly when it's not explained, because it's like, well, duh, everything modifies state. When I'm taking input and I'm transforming it to output, that's the state that gets modified. But no, what this statement really means is that the state of the mechanism that's doing the transformation does not get modified. So it's not like a finite state machine or something where it does an operation and then it changes some, like remembers some internal stuff, which will affect the way it does the next operation. Because if we're taking a whole set of things, we're transforming them and putting them into an output, and it doesn't matter which order things get done, then our transformer must be like memoryless. It must just be very simple. Bogeyman number 3, inheritance. So I know I bashed on object-oriented programming for a little bit there, but I want to sort of flip things around. There's a trend recently which has been to completely diss on object-oriented programming, which I can get behind that. That sounds fun. Dissing things is fun. But inheritance has its place. Okay, so when you're dealing with, I guess, I'll bring this back to like when I was studying databases. When you're studying databases, there's the concept of relationships, and relationships have cardinality. One to many, many to one, many to many. And the idea here is that even though we say one, in the one to many relationship, that one just represents a constant number. In other words, we could have 2 things involved. That's fine. We could have 3 things, but it needs to be a constant number. To bring it back to the actual case, the problem with inheritance is that when we do inheritance, we set up sort of an indirection structure. So to call a method from a superclass, we need to jump into a table, dereference a pointer, jump somewhere else. So the problem with inheritance is it makes methods which, although we can just call them straight away, this, do this, and it handles it for us, that becomes like a mega function call. Like it becomes very expensive. It has a lot of overhead. Now this is where the idea of sort of cardinality comes into it. When I'm making a game engine, all of my objects, my primitive objects like this ball bouncing around or these walls or something, I need to account for the fact that there could be like potentially an infinite number of those things. They need to be controlled. On the other hand, I could have some other classes which I know upfront how many of those I'm going to have. I know upfront I'm going to have 1 renderer, 1 game controller, all that sort of thing. And let's take it to extremes. Let's say that I've also got a bunch of systems. I could have 10 systems, but it's a fixed number. And so I'm not super concerned if those systems have some expensive methods, even if they're being called every frame, because there is a fixed number of them, so I can control for that. So my response to this inheritance, polymorphism dilemma is we should definitely avoid it in objects, but when it comes to there are some objects where it is easier to let them be polymorphic, and the big example that I'm thinking of is finite state machines. So let's say I have a renderer. The renderer has a bunch of states that it can be in, and those states have different behavior, and I can switch that out on the fly. Okay, there's a little bit of overhead, but I'm not going to have 1,000 renderers. I'm only going to have 1. I'm not going to have n squared systems. I'm just going to have like 10 or 20. It doesn't matter. A fixed number. That's my point. So it's sort of finding a balance between where that performance really matters and where using a little bit of inheritance helps us to develop things faster. Because the alternative is not pretty. I've been there. And this sort of leads into my next point, which is asymptotic analysis. Now, this will be super quick. In a lot of early, algorithms and data structures courses, there's a heavy focus on asymptotic analysis for good reason. Okay, there's a difference between a quick sort and a nightmare sort. But what doesn't really get mentioned is, the reality of performance, which is, Although something may be asymptotically performing better, those coefficients really matter. So if I have a small number of objects, naive collision detection may be the fast way to do it. And that's just something to bear in mind. I don't have a quippy answer there. It's just your mileage may vary. But optimization, so at least as an indie developer making little like fun things, optimization is cool and all. I always strive for it, but I'll be honest, 99% of the issues I faced in programming were issues that I caused to myself from premature optimization. If the game is just Tetris, there is probably not a big need to dive into optimization. And let me make another point. I mean, here we have this ray tracer that I made. This ray tracer is really bad. Like, not to roast my code too much, but at the time that I built this, I had some idea of how to write optimal code, and it was sort of okay, but not really. So sometimes the best optimization is just not optimizing and building your skills and learning more to get to the point where you can improve things. Second last one, memory safety. Now, let me lead by saying memory safety is good. The thing that bothers me about memory safety is that it's one of those slogans which is very easy to throw around. Oh, C++, the mascot is Keith, the rat. He blew his foot off with a shotgun because the language was not memory safe. Okay, dude. Okay. A lot of programs like Rust and Ada and other things will say, hey, we're memory safe. And it's like, okay, yeah, that's good. Being memory safe is good. But the counterexamples that they give of not being memory safe are like the worst usages of programming that I've seen. Like, people say, oh, you need to have a memory safe program because otherwise you could, have a dangling pointer situation. And I hate to say it, I know I'm going to get roasted. I feel this way. I feel like memory safety is important, but at the same time, maybe don't dereference a pointer that's been deleted. If I do this by analogy, okay? I know I've made my point already, but I'll hammer on a little bit more. Grammarly. Oh, write with confidence. And then they have these people like on the ads making like the worst spelling mistakes that no one would ever make. Is this too venomous? I don't know. But a lot of the cases where people complain about memory safety are just poor uses of memory and easily avoidable. And again, roast me for this, right? I'm putting it out there. But I think most people who are in indie game development are not making software that runs on spaceships. So I don't know how important memory safety is. Like, it crashes, okay, fine. Program crashes, that sucks. It's not the worst. And this is a big one, but this is probably one that I feel like you'll agree with me on this. And that is OpenGL. This statement that OpenGL is over. It's not the future anymore. Don't do OpenGL. I 100% disagree with that. I think that OpenGL is great, and this is my thoughts on Vulkan. This is really my thoughts on Vulkan. Vulkan is a really good educational tool. I've sort of done a 180 on this. I used to think that OpenGL was going to be around, as an educational tool, but currently I think that Vulkan is a good educational tool. It's not something I'd make anything with. I do appreciate that by learning Vulkan and practicing using Vulkan and things, I'm now aware of more patterns that I wasn't before. For instance, custom memory allocators. I didn't think about that. Game engine architecture. So the fact that Vulkan is multi-threaded, so it lets you run tasks on multiple threads. Now, you absolutely can't really do that with OpenGL. There are ways you can sort of do it, but not to the same extent. But it's gotten me thinking about architectures which are multi-threaded and sort of decoupling things, if that makes sense. As well as the SSBO model, because like in Vulkan, doing things the normal way is just, it's not easy. So it sort of forces you to use like advanced graphics programming techniques. And by doing that, you learn them. But anyway. So I think the utility of OpenGL is not going away, and that's sort of the point that I wanted to make. And I think that sort of making something is more important than worrying about APIs. And really, truly, that movement's too fast. When I finish this, this video, I'm gonna sit down and re-engineer this. But I forget what I was going to say. I don't think the OpenGL Vulkan thing was a big point. But yeah, that was it. That was my filler content. I'm joking. Which programming bogeymen do you see in your work, in your education? I don't know. Pop it down below. But I'm going to leave for now. I'm going to go update this ray tracer. I'm going to have some fun. All right. That'll be it. All the best. Bye.